Hi, I'm Justin Gerard. I have 20 years experience in software development. I've also been the founder of two startups, Decelium and FleetOps, and am the lead at Raft Consensus, where we brainstorm solutions to decentralized problems. And I wanted to talk about zero cost compliance via decentralization. This is a theme I've seen come up over the last 7 to 10 years, and it's a very powerful concept that I feel organizations don't really leverage aggressively. Um, the best custody solution is the most efficient custodial configuration. And by efficient, I mean, generally speaking, capital efficiency, but it could also be, HR efficiency or, operation efficiencies. But usually these things boil down to dollars and cents and risk. Um, you know, Custodying client data is risky. This is a snapshot of the Canadian Privacy Commissioner of Canada website where they go over um, data data responsibilities when custodying private data. The term private data can be a bit squishy. It's hard uh, to talk about what private data is, but typically, we're thinking about Visa card information, medical records, or things that could compromise an individual's safety if such information was released. Um, there's quite a list of legal requirements, and these requirements vary by both province or state and country. So if you're an organization and you plan on storing personal information for your clients, it can be a growing concern as businesses scale, that their data is handled in a proper way. And if not, you can face legal or other penalties. Um, it just kind of turns out that the cost of private data is a little extreme. So if you gather some, say, medical records from some users, and you want to have a cloud-based medical record or a cloud-based financial record, or some sort of payment system, you have to grab data, snapshots of people IDs, things like that for compliance reasons. You'll need a support staff to handle that information, and you have to vet them and vouch for them, because if they leak any of the private information, that's a legal problem for you to deal with. Your IT staff has to undergo the same scrutiny. You have to have a backup and retention policy that actually has to be executed. If not, you can be found criminally liable. You might have to satisfy the demands of audit firms and insurance companies. You might have to purchase insurance to safeguard your organization in cases of data loss. Then they will also want to audit to make sure you're following certain standard practices. Um, you might have a government audit, which is different than a self-elected audit, which can be much more invasive and much more time consuming. Um, and you might actually end up consulting with lawyers, drafting contracts, and dealing lastly with hackers, criminals, and litigation and other issues. So just by custodying something as simple as people's driver's license photos, you could have to erect a lot of business infrastructure and IT infrastructure to handle this problem. And there's generally a slow creep, meaning you grab this data and then you talk to a few people, a few advisors, and they tell you, oh, you have to store it this way. And you don't realize maybe sometimes until you're years in that you have this massive problem in your business that can be quite crippling, like hundreds of thousands of dollars a year in compliance and database management fees. So I want to talk about decentralized private data. How does that make sense, right? If you're decentralizing data and the public has a copy, if it's truly decentralized, then how is it private? So let's take a medical application example, because this is a recent project. A medical application um, entrepreneur wanted to allow people cloud-based medical record storage. And the general model that they had was that this medical record application would be installed on people's computers. And the solution that we came up with was, instead of this stuff being stored in AWS or being stored in some easy to access database, we actually encrypted the data at source. And instead of storing the data in a cloud service, we actually networked up the computers in a decentralized manner, and had, a doctor or a practitioner would input the records locally in the app. And that medical record data was then broken down into fragments, encrypted, and stored on other clients' devices or on public blockchain networks. So these encrypted fragments are practically impossible to decrypt. They're extremely secure, first of all. To be honest, without the keys, without a good key storage solution or key storage strategy, the data is not recoverable. It's that secure. But you upload these fragments to peers. And then even if the doctor turns off the PC or the lab work is done or whatever, a patient at home or another office can download any fragments they need, and given the key, can decrypt sensitive records. So a decentralized network is a little bit like a virtual database. You can think of it that way. It behaves the same as, say, a SQL database or another database, but the where the data is stored is different, right? It's not custodied by the organization. What's important about this, and this is the most important part of this whole subject, is to understand that the people storing the data have to have no legitimate material or business ties with each other. So they actually have to be the public. And thankfully, we have IPFS, Ethereum, Bitcoin, Polygon, Decilium, and a lot of other massive chains of public databases out there to use. So it's not as though someone has to go on a crusade to build up awareness of their strange new medical blockchain. These storage solutions actually already exist, so you can just tap into them and store data directly, right? This is the important part. So your clients, you could store the data in your client's app that they are running. You could store it in Ethereum, in miners running Ethereum. If you're running an event, it could be attendees at your event that installs your ticket app. It could be any community that's not directly employed or contracted by you. So the non-custodial part means that the network is run by, for you, strangers, right? So AWS and Google do have decentralized network offerings. Like, you can run a simulated blockchain network with your own nodes. You could run Ethereum and Bitcoin. You could run Geth on AWS. But what's important to understand here, and what's really, really, really critical, is that these solutions are actually custodied solutions, meaning all of the individual computers and agents that are running this network are just actually AWS. So you're not getting the custodial advantages when you use a decentralized network that's hosted for you by a large corporation. In fact, the problem is bad enough that you have to see this as centralized custody. It removes the non-custodial advantages. What I mean is, you end up in the original situation again, except now the complexity that you're dealing with around key management and backups and retention and encryption and decryption, you have those additional problems to deal with, the IT problems, but you still have all the legal problems that you had previously. So this is kind of, to apply decentralization incorrectly and not get the custody right, you actually just create a more expensive problem. And I think this is some of the feedback people have, like, oh, well, blockchain's not saving us any money, or, decentralization is not really adding any corporate efficiency. It's because you're not actually decentralizing. You're still landlocking yourself into a custody situation. And then because you have legal custody, you have to satisfy all these business side requirements. So the key is to get rid of all this bloat, right? Is to not fall into this trap. So the choice of network, like the technology you use, including who operates it, is really critical, right? The best solution in general is, again, the most efficient custodial configuration. And I just wanted to run through one practical example of why people can fall into what I call the custodian fallacy, the custodial fallacy, which is they just keep ending up trying to custody data over and over again and end up suffering the inefficiencies. So coming up with a good custody strategy is really, really important. And that's it for the video. Thank you very much for watching. If you have any questions, let me know. Thanks. Bye.